because simplifying a rational expression is our last step. So we're dealing with fractions. Now one quick rule is, remember, we can't divide by 0. So it says simplify and state the domain. When it comes to domain, that means what can I plug in to the function if I wanted to, or into the expression if I wanted to. Well, we cannot divide by 0. So if we were to plug in a 0 down here, wouldn't that be bad? 4 times 0 would be 0. So our restriction here would be x cannot equal 0. Is everybody good with that? So what would my restriction be here? X cannot equal -3. So what do? We set it equal to 0 and then we solve, and that's what it can't be. So our restrictions are our domain. So just keep that in mind. Next thing is, we can only divide across multiplication signs, never ever divide across an addition sign. So for example, these are connected by multiplication, so we can divide across, we can divide things. Right here we have x plus 3. You could never divide out the x's like this, because then that's dividing across an addition sign. You can't divide across an addition sign ever. The only time you can is if you're dividing an exact factor. So let's pretend there was an x plus 3 up here. Then you can divide out the entire x plus 3, the entire x plus 3. You guys know that rule? Okay, awesome. Moving on. So looking up here, let me show you essentially what we're doing when we simplify 6 over 8, just to make a point here. How we simplify these is we factor the top, factor the bottom, restrict, then divide. So if I factor the top, I get 3 times 2. If I factor the bottom, I get 4 times 2. I restrict. This denominator is never 0, so there's no restriction. Then we divide out exact factors. There's a multiplication and a multiplication, so it is okay to divide. So my answer would simplify to be 3/4. Do you guys get that? Yeah. Okay, so let's do that same thing here. Factor the top, done. Factor the bottom, done. There's nothing we can factor, right? It's one term. So now you'd restrict, done, and now divide out exact factors. 2 and 4 divide out to become 1/2. Then our x's divide out. So my answer is 1/2 as long as x does not equal 0. If x equals 0, it doesn't simplify to be 1/2. It simplifies to be quote-unquote undefined. We can't simplify. Does that make sense? Okay, moving on. So factor the top, done. Factor the bottom, done. Then you restrict, done. Then you divide out exact factors. Does anything divide out? No, so that's our answer. Okay, let's do this. You factor the top. What multiplies to be -1 and adds up to be 0? 1 times -1. 1 plus -1. True? Can I quick factor? Yes. So that factors to be x plus 1 and x minus 1, everybody. Now careful, because on bottom, on the test, like seriously, around 50% of you said that x squared plus 49 factors to be x plus 7, x minus 7. No. That's not true, right? It would need to be x squared minus 49, because it needs to add up to be, multiplies to be positive 49, and adds up to be 0 is this problem. 7 times -7 isn't positive 49. So right here, what multiplies to be 1 and adds up to be 0? Nothing. Do you guys see how one of them would need to be negative? So the bottom doesn't factor, so we'll just write it. X squared plus 1. Okay, so now we restrict, and then we divide. So when we restrict our denominator, we set it equal to 0. So let me show you something here. So x squared, there's this weird delayed response going on. I need to figure out what's going on with my computer. So x squared plus 1 can't equal 0. Isn't that a true statement? So solve for x. So I have x squared cannot equal -1 because I subtracted 1. Now watch what happens. When I square root both sides, something unique happens. X cannot equal plus or minus I. Isn't square root of 1 I, not -1? Right? We're not going to have imaginaries. We're only talking, we're only going to ever plug in real numbers. So this is actually, we're not going to have i's. So there is no restrictions here. I was the restriction, but we're not dealing with i's. So there are no restrictions. We can plug in any real number here. So this one's domain would be all real numbers. There was no restriction since the restrictions were i's. Then we can divide out exact factors, which, would it be appropriate to divide out x's? Nope, because that's connected with a subtraction sign, right? So is that. You can't divide across subtraction signs, so that's our answer. Nothing simplified. We factored it, right?
Like if you put x plus 1 and then divide it into x squared plus 1, you take like, it would be like x.
If we multiply it back to standard form, we would be here. Would it be okay to divide like that? No, that's dividing across the subtraction sign. Does everybody see? That's a great question, though. Okay. Back to here. So how do we simplify? Back to the top. What multiplies to be 6 and adds up to be 5? 3 times 2, I quick factor. So on top I have p plus 3 and p plus 2. Now on bottom, I factor the bottom. What multiplies to be negative 4 and adds up to be 0? 2 times negative 2. So the bottom quick factor is to be p plus 2, p minus 2. You have to restrict before you divide. So our restriction here, p cannot equal what? Negative 2, right? We set it equal to 0 and solve, so that would be negative 2. And then right here our restriction is 2. Now divide out exact factors. So then left on top is our p plus 3. I have just nowhere to write. P plus 3, and then left on bottom was p minus 2, and that is our answer as long as p does not equal 2 or negative 2. You restrict before you divide. Okay. Alright, so it says simplify. How do we simplify? Factor the top, factor the bottom, divide out exact factors. You shouldn't really need to take notes during this part, because this is just making sure we're good for our last step of all of the problems for this unit. So we factor the top. It multiplies to be negative 15 and adds up to be 2. 5 times 3? Negative 3. Can I quick factor? So the top factors to be x plus 5 and x minus 3. Now looking at the bottom here, we would factor this. What multiplies to be negative 18 and adds up to be negative 3. 6 times 3, negative 6. Then guess what? Like 50% of people did on the test with something like this. They quick factor. You can't. So we're going to long factor. Now I like to put my final factors in the same place, so I'm going to keep all my work over here. So I drop and break. So watch. Drop. So I drop down 2x squared. I drop down negative 9. And then I'm breaking down the middle term as these two factors. Minus 6x plus 3x. Factoring by grouping. So then I pull out a 2x. Left is x minus 3. I pull out a positive 3. Left is x minus 3. So then didn't the fact... Now everyone, people are thinking you can stop there. That's not the final answer. I saw people on this test, a few people in this class were saying this or this. 2x plus 3. Yes, it's this, but it's not this. Does that make sense, everyone? Okay. So we have an x minus 3 and a 2x plus 3. Now you'd say, I got to restrict before I divide. Don't start getting tempted, because people will get to the test and they'll always divide and then restrict, and then they've missed 7 points because there's 7 problems. Does that make sense? So x cannot equal what for that? 3 and? So we should be doing it, sounds like we should actually do that math, because a lot of us are getting it wrong. Subtract 3, subtract 3. 2x equals negative 3. Divide by 2, so it's negative 3 halves. So x cannot equal negative 3 halves. So now divide out exact factors. So my answer is x plus 5 over 2x plus 3. Are we all good?
Yeah.
Okay, I think we get how to simplify. Okay, I think we get the picture almost, except for one thing. It says simplify. We factor the top. I was devastated. My heart was shattered when people said that this does not factor. 2 perfect cubes factor. What's the cube root of q cubed? What's the cube root of 8? 2. So it does factor. So the top factors to be q and 2. Front times the front is q squared. Front times the back is 2q. Back times the back is 4. I literally croaked dead when 50% of people said that didn't factor. Now if this sign's a minus sign, this sign's a minus sign. The next sign is plus, and the next sign is always a plus, right, everyone? Now we'll factor out the bottom. Oh, one question for you. In 2 perfect cubes, will the quadratic ever factor? No, it won't, but we could check. It doesn't. It won't. Now factoring out the greatest common factor, we pull out a 3q. So then divide by 3q, divide by 3q. So then left was q minus 2. Restrict before you divide. So right here my restriction is q cannot equal 0 or 2. And now let's divide out exact factors. So left on top was that, left on bottom was that, and there's my answer. I'm not going to rewrite it. We get the picture. Yes?
Where did the q squared plus 2q plus 4?
Because this is 2 perfect cubes, and we've learned how to factor it. So we cube root the front thing, we get a q. We cube root the back thing, we get a 2. Here's the front, here's the back. So this is just a method we've learned. Q and 2. Front times the front. Front times the back. Back times the back. It was just a method we learned.
Okay.
Is that ringing a bell now?
Yeah. I wasn't there for that class, but I'll go watch the
Gotcha.
video. So.
Okay. Alright, so now looking at this one, there's a reason I'm just doing this one. I'm not going to go through the whole thing. I'm just going to show you. It says simplify. We'll factor the top, factor the bottom. The bottom can't be factored unless it's in standard form. So I'm just making sure you guys understand this. We have negative 3x plus 1. Is that considered factored? Nope, we need to pull out a negative 1. So we pull out negative 1, and then left is 3x minus 1. That's what the denominator would factor to be, everybody. Just a reminder. A lot of people say, oh, it's factored. But no, it's not, actually. Okay. All right, now we're going to learn how to multiply fractions. Still, at this point, you don't need to be taking notes quite yet. I'm making a point here. There are two ways to multiply fractions. We can do it the long way or the easy way. So let me just show you. With numbers, it's a little iffy, because people will say, well, I think the first way is easier. The first way is not easier when we get harder stuff. So I'm making a point here. We could multiply, when multiplying fractions, we do not need a common denominator. We literally just multiply straight across. So we could actually multiply it out and say, 2 times 4 is 8, right? So we get some big thing here. 3 times 6 is 18. Now what we would do is factor out the stuff that's in common and divide out exact factors. So what do they both divide by? 2, right? But even more than that, don't they both divide by 4? Yeah. So if this divides by 4, it becomes a 2. If this divides by 4, it becomes a... You're right. So this divides by, good point, so they both divide by just 2 then it looks like. So this divides by 2 and becomes a 4. This divides by 2 and becomes a 9. Okay, well that's a good point. So see, the reason I did that is for this next reason. Okay, we'll pretend. Okay, so the easier way to do it, because I wouldn't have even made that error had I done it like this. That was actually a perfect example. Factor all the pieces as is before you multiply them together. 2, there's no factors of 2. 3, no factors of 3. Well, 4 has factors 2 times 2. Do you agree? Then on bottom, 6 has factors 3 times 2. So now what do? Multiply straight across, but don't actually multiply them together. So on top, I have a 2 times 2 times 2, don't I? Now on bottom, I have a 3 times 3 times 2. Now divide out exact factors. So what's on top? What's on bottom? So do you see how I wouldn't have even messed up had I done it that way? Does that make sense? Okay, so that's the steps we're going to take when doing hard ones. Factor each piece, multiply straight across, but don't actually multiply it out, and then divide out exact factors. Here are the steps. Take a picture of it. I'm not going to wait for you to write it down. Yes. Okay, so factor each piece. On bottom, this would factor to be x plus 2, x minus 2. Are you following me?
Yes.
X plus 1, on bottom I would factor out an x, left to be x plus 2. Factor each piece. Second step, multiply straight across, but do not multiply. So on top I have x plus 2, I have x plus 1. It is so important you don't actually multiply them out. We have x plus 2, x minus 2, x plus 2, and then I'm going to put the x in front because it's just considered prettier. Do not multiply it out. Now your third step is to restrict your denominator. So x cannot equal what? 0, negative 2, or positive 2. And then that one's already been listed, negative 2. So we're good. Now we're to our fourth step. Divide out exact factors. Ding, ding. Isn't that it? So left on top is x plus 1. Left on bottom is x, x minus 2, and x plus 2. Now everyone listen. That is our answer as long as x does not equal that. Now, you could put it in standard form. Is factored form or standard form better? Don't answer that. Neither. They're equal. Standard form and factored form are equally good. So why would I go and put it in standard form when it's in factored form and that's just as good as standard form? Do you guys understand why I'm not doing it? Not that it'd be wrong, it'd still be right. It's just you risk getting it wrong, multiplying it all together wrong. So just stop. That was easy, right? You follow those steps, it's actually easy to do this stuff. Okay, let's do another one. Okay, this one, you won't need to write down this one. I'll tell you when to start writing down. This one's still too easy to even, it's not worth your time writing down. I'm making a point. Our first step, and you should be saying this on the homework on every single problem to yourself. This is how we study. Some of you need to learn how to study it better. This is how you should be studying. As you go to each problem, say, when multiplying, I factor each piece. Okay, that's done. Now my second step is to multiply straight across, but not actually multiply. So we have a 9x, and we have an x plus 3. True? Then we have a 2, and then we have times 3 times x. Isn't that the same thing? Is 3x connected? By a multiplication sign. Aren't we all good? Okay, then you'd say, now I restrict, so x cannot equal 0, and now I can divide out exact factors. 9 and 3 divide out to be 3 over 1, true? X's divide out, that's all it divided out. Left on top was a 3, and x plus 3, and then on bottom left was a 2. I could multiply it out and put it in standard form, but not necessary, because that's just as good. So I'm done. Okay, let's do one. Now write this one down. It says simplify. So in your head, you're going to go through the steps. When multiplying fractions, I factor each piece. That's my first step. So as you're writing it down, I'm going to be working on factoring it off on the side. So we do what multiplies to be negative 15 and adds up to be 2. So that would be 5 times 3. So then we would have a negative 3 and positive 5. Then you would check, how do I factor this? Well, I can quick factor. Now I have a special place where I put my final factors. So right here I have that factors to be x plus 5 and x minus 3. Now I'm going to cross it out because I factored it. Moving on. X plus 1 is already factored with 2 terms. I always put parentheses. Moving on. Times. Looking at this, we'd say, how do we factor that? Well, that has a greatest common factor, x. So I would pull out an x. Divide by x. Divide by x, leaving me with x plus 7. Now on bottom here, you'd say, well, I have a quadratic. I'm going to do my work off on the side because I want all the pretty stuff here only. Well, multiplies to be negative 21 and adds up to be 4. So that looks like it would be, good, 7 times 3, and it would be negative 3. And then I can quick factor because my leading coefficient's 1. So that factor to be x plus 7 and x minus 3. Check, you factored all the pieces. Second step, multiply straight across, but do not, in huge capital letters, actually multiply it out. So I'm going to put x in front. It's just considered prettier. So then I have an x plus 5, an x minus 3, and an x plus 7. The order doesn't matter on the rest, but I do like to put x in front. Then I have x plus 1, I have x plus 7, and x minus 3. On your homework, it would not hurt to label your steps. This is my second step. Then my third step is to restrict. So x cannot equal negative 1, negative 7, or 3. Do you agree? Mm-hmm. And then we're to our fourth step where we actually divide out exact factors. So it looks like x plus 7, x minus 3. So then left on top was x plus 5, and then on bottom was x plus 1. And then you could just circle step 3 and 4 because there's your answer. Follow those steps every time. If you can factor, then and you follow these steps, you're good. Okay, okay, this one. So you say, when multiplying fractions, we multiply each piece. So, I mean, we factor each piece. What multiplies to be 1 and adds up to be 2. 1 times 1, right? 1 plus 1? So I can quick factor that piece to become y plus 1 and y plus 1. Awesome, moving on. What multiplies to be negative 6 and adds up to be 1? 3 times 2, negative 2. Then careful, because we cannot quick factor. We'd have to drop and break. 3y squared, negative 2. We break down our middle term, plus 3y minus 2y. And then factoring by grouping. So pull out a 3y, left is y plus 1. Pull out a negative 2, left is y plus 1. And I got to pull out y plus 1, and then left was 3y minus 2. So now you'd say, okay, now I've got that piece. Y plus 1, and then 3y minus 2. Now, right here, how should I rewrite that? I'm doing my work over here. I only put my final answers in a special spot. So, I write it as negative 3y plus 2, right? Factor that. What would we pull out? So pull out negative 1, and then divide by negative 1, divide by negative 1. So then left is 3y minus 2. Now factoring out this, what multiplies to be 4 and adds up to be 5, 1 times 4, I can quick factor. So that factors to be x plus 1, oh, it's a y. So we have a y plus 1 and a y plus 4. We've just done step 1. Now step 2, multiply straight across, but don't actually multiply. I put negative 1 in front. I have y plus 1. I have y plus 1. I have 3y minus 2. On bottom, y plus 1, 3y minus 2, y plus 1, and y plus 4. Restrict. Y cannot equal negative 1. What for that? 2/3. We've already listed that, and so then negative 4. Now we're on, that was step 3, and then on step 4, we'll divide out exact factors. Ding, 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 ding. Isn't that it? Ding, ding. So what was left on top? -1, and then on bottom, y plus 4.
So if we were to like go through and do all that and there was like a negative, like where that one was like -1 and then like -1 again, when we get dark we get some -1s.
Yep, because they divide out, don't they?
Like, no, but like they can't equal
Oh,
-1.
oh, I see. You're saying if you
Yeah.
list it out twice, would you get it docked wrong? No, it's just doing extra work.
Okay.
Hey, are we getting the picture here?
Yeah.
Okay, awesome. Then I just want to make sure, because when we got to the test, some people freaked out when they saw some advanced, a little bit more advanced factoring. So I just want to make sure, this will be the last one I do with multiplication. So how would I factor this? Good question. That is, but the thing is, we should check, is there a greatest common factor? No. So then we move on, then what? Yes, ignore the q. It's quadratic. Look at it. Quadratic in form, isn't it, everyone?
Yeah.
So ignore the q. So remember that that's just going to be p squared plus 5p plus 6. Then you say, well, multiplies to be 6 and adds up to be 5. 3 times 2. So then I can quick factor that to be p plus 3 and then p minus 2. No, p plus 2. My bad. Now, just insert a q, right? Don't we just do that same thing here? Well, multiplies to be 6 and adds up to be 7. 1 times 6. Can I quick factor? No, I'd have to long factor. Do we get the picture here?
Yeah.
Okay, then I'm not going to continue. I just wanted to make sure we can factor something of this caliber. Yes.
What would we do if one of them is cubic?
It depends on the problem, because there's many different things we could see. Like if you're saying if this was p cubed,
Yeah.
there's no greatest common factor, and then it's not 2 perfect squares, it's not 2 perfect cubes. So in that, we haven't learned how to factor anything like that. So you're always going to have something that we have learned how to factor. Otherwise, you would just leave it. Good question. Okay, so I think we get the picture here. All right, so then let's go ahead and look at dividing now. Here is how dividing works. Everyone ready for the cute little saying? Dividing fractions is easy as pie. You flip the second fraction and you multiply. Yeah. So we actually already know how to do it. Dividing fractions is easy as pie. You just flip the second fraction and you multiply. Didn't I just say it like that? I just said it like that last year, didn't I?
I thought you like
I don't think with this one. Maybe you're thinking of something else. Dividing fractions is easy as pie. Flip the second fraction and multiply. Is that better? Okay. Okay. So we would say, okay, divide. We got to take the second fraction, which is this, and flip it and multiply. So on top now is 15y to the 5th. Then on bottom, we have a 4x squared, right? And then don't we know how to do that? We just learned that, right? Factor each piece. Multiply straight across, but don't actually multiply. Restrict, divide. Now here is one additional thing in your notes, right here. There is one thing to note when it comes to division. So in your notes, write this. With division, one thing to note. We actually are going to have an additional restriction. So let me explain why. So if I give you an example, a divided by b divided by c divided by d. Let's just go through some scenarios here. A divided by 0. Can we divide by 0? Can 0 be in the denominator? No. So we would have to say that we've got to restrict. B we've got to restrict. B cannot equal 0. True? Okay, let's look at scenario number 2. A divided by b divided by 0 divided by d. Now just in this part, it is okay to have a 0 in the numerator, right? Yeah. Good. In the big picture, though, because that becomes 0, in the big picture, now we have divide by 0. So because of the fact that it would simplify to be 0, then making it in the big picture 0, this also can't be 0. Then the final case is this one, where you see a divided by b divided by c divided by 0. We can't have 0 in the denominator. So now we have to go back, and we actually have to also say d cannot equal 0. So this one has 3 places we have to restrict. We have to restrict here, here, and here. Where with multiplication, we only have to restrict the bottoms, right? So with division, you just have to restrict everywhere but the top corner. So right here, my top corner is 20, x to the 5th. That's the only place I don't have to restrict. I got to restrict everywhere else. So I'm going to erase this. But you would have to remember, yeah, you've written it as multiplication, but it was originally division, so it has that extra restriction. So we got to restrict right here. So our restriction right there is y cannot equal what? 0. Now restrict here. Y cannot equal 0, right? Set that equal to 0. You divide by 15. 0 divided by 15, 0. Then fifth root it. Fifth root is 0, 0. So y cannot be 0. We've already listed that. Now restrict here. X cannot be what? 0, right, everyone? Okay, we've restricted. Now multiply straight across. So we would have a 20 times 15 times x to the 5th times y to the 5th. Then on bottom I have a 3 times 4 times y times x squared, right?
So it's always the top left corner that you're not going to
Yeah, it's the very start. Like the very, yes, the A.
Why do you have to restrict the top right? I mean, why can you not be 0?
Which part?
The D, I guess.
Because that would be a 0 in the denominator.
Okay. But if you flip it, you want it to work?
But it's really not flipped. I mean, it is flipped, but it was a division problem. Does that make sense?
Yeah.
Okay, so now let's divide out things. Across multiplication signs, it's okay. So 20 and 4 divide out to become 5. This divides out to become 5. Then x to the 5th and x squared divide out to become x cubed on top. Sorry,
Just kidding. No, just kidding.
Okay. Okay, and then y to the 5th and y become y to the 4th on top. So left on top was 5 and 5, which is 25. Then we had an x to the 3rd and a y to the 4th, and then divided by 1. So we're done. So our answer was that right there. Okay, we're almost done with this lesson. So let's just do a couple division problems, maybe even just one, and then we can call it good. So you'd say, okay, dividing fractions is easy as pie. We flip the second and multiply, right? But remember, with division, we've got to restrict everywhere except here, right? Okay, so just keep that in mind. So we flip the second, giving me this. 2x cubed minus 4x squared plus 8x. And then on bottom, I now have x cubed plus 8. And then you'd say, but this is really a division problem, so I've got to restrict here, here, and here. Well, to restrict, we're going to want it factored. So let's factor each piece. So with multiplication, our first step is to factor all the pieces. So factoring this, what multiplies to be negative 12 and adds up to be negative 4, 6 and 2, negative 6. It quick factors. So we have an x minus 6, we have an x plus 2. On bottom, we'll pull out a 2x squared. Divide by 2x squared, divide by 2x squared, leaving me with, looks like 2x minus 3. Then I'm going to pull out a 2x. I'm going to do it over here because I feel like it might factor more. So then left is x squared minus 2x, is it? Yeah? And then plus 4. And then you see what multiplies to be 4 and adds up to be negative 2. 1 times 4, 2 times 2. Nope, it doesn't factor. So times by 2x and then a quadratic that did not factor. And then right here, we have 2 perfect cubes, which we use our trick to factor. X and 2, right? 2 perfect cubes. So we have an x and a 2. Front times the front times the back times the back. Then you'd say this sign and this sign are the same. The next sign is opposite. The last sign is always plus. All right, let's restrict before we divide. With a quadratic and a 2 perfect cubes, it won't factor. So let's restrict. Now careful, the only place that doesn't get restricted is right here, right? Restrict there then. X cannot equal 0. X cannot equal. It's okay, my handwriting is, it's a little jumbled right there. So 3/2, I gotta restrict there. Nope, set it equal to 0, add 3, divide by 2. Right? Yeah. So 2x minus 3 can't be 0, so you add 3, then divide by 2. So it'd be positive 3/2. Okay. And then right here, y restriction is 0, we've already listed it. This is a quadratic that doesn't factor. Wouldn't that need quadratic formula? Then we don't have a restriction on it. Moving on. Restricts there. Negative 2, and then that doesn't have a restriction. So there's our restrictions. Now divide out exact factors, can't I? Multiply straight across. Is anyone going to be mad if I just don't rewrite it? Do you get what I'm saying? Okay, let's divide out exact factors. 2 and 2, divide out. We have an x up here and an x squared down here. Won't that divide out to be 1x on bottom? X plus 2, x plus 2. Oh, those x squared minus 2x plus 4's cancel out. And that's it. So left is x minus 6 on top. On bottom, I had an x, and I had a 2x minus 3. And I just had that extra restriction. All good with that? Because we had an x squared right here, and an x up here. So x and x squared would simplify to be 1x down here. Good questions. Okay. So I'm not going to do any more. If you guys are good, I just want to make sure. I'm going to ask you one quick question. I would flip the second and multiply, right? So I would restrict there, there, and there, right? Okay, just making sure. Okay, awesome. If it gave it to you in function notation, could you do it? F times G, and then how do we multiply things? Factor all the pieces. Multiply straight across, but don't actually multiply. Restrict, divide. The steps don't change. Okay, I'm just going to, this is quick. Write an expression that is undefined at 2. Undefined at 2. So that means in our denominator, what would we have as a factor? Yep. Wouldn't that be undefined at 2, everybody? Wouldn't that make it 0? Do you guys see? Yes. Undefined at 2, so x minus 2 would be the factor. Now on top, it says create your own expression. The top does not matter, does it? I could put a 1. I could put a 5. I could put an x. It doesn't matter. We're creating our own. So it says right here, create an expression that's undefined at 2 and negative 1. So what would my two things be? Good. And then on top, it doesn't matter what we put. I could put a 7 for all I care, right? I could put 7x squared, couldn't I? It doesn't matter. Okay, sweet. Now I'm going to have you practice some of those. Do not talk about anything other than math. We have to learn another lesson. And if you combine the lesson ideas in your head, that's when it starts getting hard. Right now you think it's easy. Yes, it is. By itself, it's easy. Once you learn the next lesson, if you jumble the steps, say goodbye. Wave goodbye to your test.